Second subtopic, resultant magnetic field produced by current carrying conductor. So in this subtopic, you should be able to sketch the resultant magnetic field diagram at a point. Okay, so it limits to two current carrying straight wires and it's only two-dimensional. And then you have to be able to determine the direction of the magnetic flux by using right hand rule. Okay, and then you have to also be able to determine the magnitude of the magnetic field by using all of these equations for each of this. Okay, right, so resultant magnetic field produced by current carrying conductor. So when a current flows in a conductor wire ataupun coil, remember a magnetic field will be produced. Okay, so the direction can be determined by using the right hand grip rule, okay, as shown in this diagram here. Okay, so the thumb is telling us the direction of the current, whereas the rest of the fingers is telling us the direction of magnetic field. Okay, magnetic field. Okay, right, so let's look at the magnetic field of a long straight conductor which is carrying current. Okay, so these are the patterns around a straight conductor which carries current lah. Okay, so how do we determine the direction of this magnetic field is by using the right hand grip rule. Okay, so since the current is pointing upwards, let's try and draw. The thumb is here. Okay, so basically our fingers, the other fingers, would be pointing to here lah. Okay, so that's why dia punya lukisan so that's why the drawing of the magnetic field is begini. Okay, because it all points following the other fingers based on the right hand grip rule lah. Okay, so if you actually it's easy to draw it this way. So lukis macam ni lah, okay, selalu. Right, so it's the same thing lah kalau dia, if you draw it like this, so our direction of the fingers is still telling us it's pointing anti-clockwise. The direction is anti-clockwise. Okay, right, so let's look for current into the page where the our thumb is here, and then don't actually know how to draw this. Gitu ka to. Wala lah. So the current is the magnetic field is this way. So it is clockwise. Okay, so clockwise, so that's why the direction here is clockwise. Okay, so that is for current into the page. Now let's look when the conductor is placed in a vacuum. Okay, so untuk ini so the magnitude of the flux density can be calculated using this equation lah. Okay, so so ini this is the equation that you need to use when you come across a straight carrying conductor punya questions. Okay, boleh lah. Okay, so yeah, itu je. So now let's look for circular coil pula. Okay, so the magnetic field lines pattern around a circular coil is this one lah. Okay, so this one do the same thing, right hand grip rule, and then remember at this point tengok je lah which direction. Is it pointing up or pointing down? So the arrows will follow lah. Okay, right, so for this circular coil you will use the equation, this one. Okay, remember semua direction ni for the magnetic field lines will be using right hand grip rule. Okay, right hand grip rule lah. Okay, macam ni dia tunjuk di sini, dia guna right hand grip rule just to determine the magnetic field lines. Okay. Okay. What else? Solenoid pula. Okay, so solenoid is an electrical device where a long wire has been wounded into a succession of closely spaced loops with geometry of helix. Okay, kamu tahu juga kan apa solenoid? So, untuk solenoid punya pattern, macam ni lah, dia tunjuk macam ni. So remember, X is entering the page, this one is leaving the page, okay? So the magnitude of the magnetic field intensity at the center, okay, center, midpoint, ataupun inside of n-turn solenoid. Remember, solenoid ada berapa number of turns, so you will be calculating it using this equation shown here lah, okay? Using this one. This one untuk center lah. And then untuk field intensity at the end pula, at the end of the solenoid, you'll use this equation. Okay, so usually the question will specify lah which one dorang mau. Okay, so mu naught is this one, and then R is distance of a point from a straight conductor. This one is for straight conductor punya equation. N is number of coils, I is current, small letter n is the number of turns per unit length. Per unit length, okay. Alright, I guess that is for subtopic number 2.